In the previous video, we talked about making graphs of sine and cosine. So just as a quick review, you might notice that there's some labels on these axes that aren't usually on them when we're graphing sine and cosine. Because when we draw a basic graph of sine, A is 1, so we go up and down 1 from the middle. And B is 1, so the period is 2 pi, and 2 pi divided by 4 is pi over 2, so our critical points are here, 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 and here. And we start in the middle, and we go uphill, so this would be at a peak, this would be at the middle, this would be at the valley, and this would be at the middle. And when we continue the wave backwards, this would be at the valley, the middle, the peak, and the middle. Now, if we superimpose our cosine wave on top of this, it starts at the peak. It has the same critical points going across as sine, but since it starts at the peak, and then it goes to the middle, to the valley, to the middle, and the peak, and again, continuing the pattern backwards over here, we get that. So when we learned how to make the chart of the values of the special trig functions, we learned that tangent was sine divided by cosine. So if I use this to help me figure that out, remember, sine was the solid line, cosine was the dotted line. 0 divided by 1 is 0. So I'm going to have a point right there for tangent. When I go here, 1 divided by 0 is undefined. So that means I'm going to have a vertical asymptote at pi over 2. When I go here, 0 divided by negative 1 is 0, so I'm going to have a point there for tangent. When I go here, I've got negative 1 divided by 0 is undefined again, so I'm going to have a vertical asymptote for tangent. Here, again, I get 0 over 1, so it's 0. If I go backwards, here I have negative 1 over 0, so it's undefined. Here it's 0 over negative 1, so there's a point for tangent here. Here it's 1 over 0, so it's undefined again. And here it's 0 over 1, so it would be back to 0 again. But that doesn't give us a whole lot of information. It gives us asymptotes and points on the midline. So let's go partway between at these pi over 4s. Pi over 4 is halfway between 0 and pi over 2. If you think about the chart, at pi over 4, the sine and cosine are the same. So sine divided by cosine is going to be at 1, which is the top line. When we go over here to negative pi over 4, the sine and the cosine have the same absolute value, but one of them is positive and one of them is negative. So when you divide two numbers with the same absolute value but different signs, you get negative 1. And that's going to happen at all of these pi over 4s. At the one to the left of the point on the center, it's going to give you negative 1. And at the one to the right of the point in the center, it's going to give you a positive 1. So going back here, we're going to have a negative 1 here, and a positive 1, and here we're going to have a positive 1. Well, because we have all these points of non-existence, that means we're going to have sections that don't touch. And in fact, if you plug some other points in here, what you're going to see happening is, for the part below the midline, it curves downward. And for the part above the midline, it curves upward. So it's kind of a long, stretched out S-curve. And it repeats over and over. But notice the whole pattern repeats more often than the sine and the cosine waves did. You can get one whole period of tangent between negative pi over 2 and positive pi over 2. And it's centered right at the middle point. So that's why the normal period for tangent is pi instead of 2 pi, which is what it says down here. Their domain isn't quite all real numbers, because every odd multiple of 2 pi is a place where it doesn't exist. But the range goes from negative infinity to infinity, because these can keep going down all the way along the vertical asymptote, and they can keep going up all the way along the vertical asymptote. So if you want to know what, like I had the critical points of the tangent function, instead of starting at 0 and going 4 to the right and 4 to the left, I have 0 in the middle, and I go 2 critical points to the right and 2 to the left, and that gives me 1 full period. And then I can just continue that on one or the other sides of the one that I draw first. The A, notice it's the same formula here, but the A, you don't really call it amplitude because this is not a wave anymore, but it does give you a key place, a key point. These high and low points, as it goes up through and down through them, are a distance of A units away from the midline. So we do need to take a note of that point A. And B is still going to help us find the period. But since the normal period is not 2 pi, it's pi, to find the period for tangent, you divide pi by B. And then to find the distance between the critical points, you divide that by 4, or multiply it by 1/4. Frequency would be B over pi, because again, they're still reciprocals of each other, but you don't really talk about it so much with tangent because it's not really a wave. So for a tangent, if I'm sketching a tangent, I'm going to start, I'm trying to get a place where I can write here and you can still see the chart. So I'm going to start with my pretend axes like I did for sine and cosine. I'm going to go up and down my A units, and I'm going to mark off 2 to the right and 2 to the left. And at those 2 points, I'm going to have vertical asymptotes. Halfway between them, I'm going to have a point in the middle. To the left of it, I'll have a point at halfway between that point and the left asymptote. I have a point on the low midline. Halfway between that middle point and the higher asymptote, I'll have a point on the upper midline, and then I just curve downward below the x-axis, or the pretend x-axis, and upward along it. The method I use to set it up is going to be very similar to what we did with sine and cosine. So, for example, here's a trig function in standard form. So first we want to identify what A, B, C, and D are. A is always the number that is multiplied by the trig function, so that's 3. Since it is positive, this is going to not be flipped vertically. And its amplitude is going to be 3, because that's the absolute value of 3. B is the number that's multiplied by the x, so that's going to be pi over 2. So to find the period, I take the normal period for this function, which is not 2 pi, but just pi, and I divide it by b, which is pi over 2. Now, sometimes people get a little confused dividing by the fraction, but remember, to divide by a fraction is the same as multiplying by its reciprocal. So notice the pi's will cancel, and I just get 2 for the period. So the distance between the critical points is going to be 2 divided by 4, which is 1/2. C is 2. Well, it's actually negative 2 because this should be minus C. So that means we shifted to the left 2. And D is negative 1. So that means we shifted down 1. So my starting point is going to be CD, which is negative 2, negative 1. So I'm going to draw my axis. I should have done those dotted because they're not the actual XY axis. And this center point is the point negative 2, negative 1. Now, like I did for sine and cosine, I'm going to make a mark equally distance above and below, and the distance between this point and those 2 points is a. So if I add 3 to -1, this would be +2, and if I subtract 3 from -1, this would be -4. And those are going to be my high and low guidelines. Now, the distance between my critical points is 1/2, and I'm starting at -2. So going to the right, 2, not 4, and to the left 2, this is where my vertical asymptotes are going to be. And these are distances of 1/2 in between. So -2 plus 1/2 would be -3/2, plus 1/2 would be -1. -2 minus 1/2 would be -5/2, minus another 1/2 would be -6/2, which is -3. Now, in between these lines, between here and here, is going to be 1 full period of tangent. So to get 2 full periods, which is what I always ask for when I'm doing graphing, then I'm just going to go the same space I went here. I'm going to go 1, 2, 3, 4 more. And that'll be another asymptote because they're 4 critical points apart. And then I'm just going to keep adding 1/2. So -1 plus 1/2 is -1/2, plus 1/2 is 0, plus 1/2 is 1/2, plus 1/2 is 1. Now, for a normal tangent graph, it's going to have a point at where the 2 axes, quote-unquote, crossed. At the critical point halfway between that point and the asymptote to its left, there's going to be a point on the low guideline. One to the right, halfway between that point and the one on the right, there's going to be a point on the higher guideline. And then I curve downward through that point, going below the x-axis, and upward through that point, going along above the x-axis. Then I'm just going to copy this in this little section. So it has a point in the middle, a low point here, a high point here, and this is my second tangent branch.